A student is reviewing the various effects that can be plotted on a dose response curve. He has observed that certain drugs can work as an agonist and an antagonist at a particular site. He has plotted a particular graph, as shown below, and is checking for other responses that can be measured on the same graph. He learned that drug B is less potent than drug A. Drug B also reduces the potency of drug A when combined in the same solution. However, if additional drug A is added to the solution, the maximal efficacy Emax of drug A increases. He wishes to plot another curve for drug C. He learns that drug C works on the same receptors as drug A and B, but drug C reduces the maximal efficacy Emax of drug A significantly when combined with drug A. Which of the following best describes drug C? Answer A, competitive antagonist. B, non-competitive antagonist. C, inverse antagonist. D, for agonist. C, reversible antagonist. So the correct answer is B, the effect of a drug after it binds to its receptor and produces a response can be reduced by another drug. This is called antagonism. In the given scenario, drug C is a non-competitive and irreversible antagonist. A non-competitive antagonist is chemically unrelated to the drug and binds to a different allosteric site, which prevents activation of the active site. Therefore, drug C blocks and prevents the action of the agonist. It is important to note that irreversible antagonists bind to the active site through strong covalent bonds, where reversible antagonists bind to the active site through weak ionic bonds. A competitive antagonist reduces potency of an agonist, and a non-competitive antagonist reduces efficacy of agonist, where when an irreversible antagonist binds to a receptor, an irreversible antagonist reduces the number of receptors and active sites for the agonist. Because fewer receptors are active, an irreversible antagonist results in a downward shift of the curve. See the figure below. Increasing the concentration of agonist at the binding site does not have any impact on the effect of a non-competitive antagonist. This is because the receptors are irreversibly occupied, prohibiting the agonist from binding to the receptor site In short, non-competitive antagonists reduce the maximal effect of agonists. Option A and E. Drug B is a competitive antagonist in the present question. A competitive antagonist prevents an agonist from binding to its receptor and decreases its potency. An antagonist is competitive because it is chemically similar to an agonist and competitively binds to the same site. The binding is irreversible in nature due to weak ionic bonds. Increasing the concentration of agonist at the binding site reduces the effect of a non-competitive agonist. A competitive antagonist reduces the potency of an agonist without having an effect on Emax.